Dear student, today we will take the 12th lecture for square wave potential. As you know, in the last lecture 11, we have studied the square wave potential with finite walls, finite depth and finite width, okay, in which the potential energy of the particle was given to you and you are asked to find out the energy eigenvalue spectrum of a particle moving in a potential field given by, okay, you are asked to, our problem is to find out the energy eigenvalue spectrum for the particle whose total energy is negative, which is moving in a potential field given by Vx is equal to 0, okay. The potential energy of the particle is 0 in the region 1 from minus infinite to minus. The potential energy of the particle is minus V0 in the region 2 from minus A to plus M. And potential energy is again 0 in the region from plus A to plus infinite. Okay, so I have plotted a graph in the last lecture from x is equal to minus infinite to x is equal to minus A is region 1 in which the potential energy of the particle is 0. From x is equal to minus infinite to x is equal to minus infinite to x is equal to minus A is region 1 in which the potential energy of the particle is 0. So we get a straight line graph. From x is equal to plus A to x is equal to plus infinite, from x is equal to plus A to x equal to plus infinite is called region 3 in which the potential energy of the particle is 0. So x is equal to minus infinite to minus A, x is equal to minus infinite to x equal to minus A is region 1 in which the potential energy of the particle is 0. X is equal to plus A to x equal to plus infinite, x equal to plus A to x equal to plus infinite is region 3 in which the potential energy of the particle is 0. And in the square wave region 2, from x equal to minus A to x equal to plus A, the potential energy suddenly falls from 0 to minus V0, right? So in square wave region 2, from x equal to minus A to x equal to plus A, the potential energy of the particle suddenly falls from 0 to minus V0 electrons. So in the region square wave region 2, from minus A to plus A, the potential energy is minus V0, right? The potential energy of the particle has the shape of well with vertical sides. The potential energy of the potential energy of the particle has the shape of a well with vertical sides. Therefore, such potential is called square wave potential, right? Okay. In the last lecture 11, okay, I quickly revise it. We have obtained Schrodinger equation in region 1 and its solution. We also obtained Schrodinger equation in region 2 its solution, and also obtained the Schrodinger equation in region 3 and its solution. So in the last lecture 11, we have solved Schrodinger equation in region 1, region 2 and region 3, and we also written the solution of Schrodinger equation in region 1, that is U1. Solution of Schrodinger equation in region 2 is U2 and solution of Schrodinger equation in region 3 is U3. Okay. We know that the particle, the total energy of the, yes, this V0. Suppose V0 is minus 1, minus 2, minus 3, minus 4, minus 5 electron volt. So this V0, V0 को क्या बोलते हैं? V0 is called the V0 which is 5 electron volt as for example is the depth of potential well. So V0 is equal to 5 electron volt is called the depth of the potential well, and A on right side and A on left side is called the half width of the potential well. So the depth of the potential well is V0 and small a is the half width of the potential well. Now the particle whose total energy is suppose minus 3 electron volt negative, okay, the particle whose total energy is suppose minus 3 electron volt negative hai, that particle cannot go in region number 1 and region number 3. So particle whose total energy E is negative minus 3 electron volt cannot enter in region 1 and region 3. So region 1 and region 3 are called classically forbidden regions for such particle. So particle whose total energy E is minus 3 electron volt, the particle whose total energy is negative, right, cannot enter in region 1 and region 3, right? So region 1 and region 3 are called classically forbidden regions for such particle. So such particle whose total energy is negative have to stay within the potential well between x to minus m plus m. So particle whose total energy is negative, the particle whose total energy is negative, suppose minus 3 electron volt, have to stay within the potential well between x to minus m plus a. So we can say that such particle is bound by the potential. Okay. Now you know the time independent Schrodinger equation. The time independent Schrodinger equation of a particle is d square u upon dx square plus 2m upon h square E minus Vx is equal to 0, right? where you know u is the wave function of the particle, m is the mass of the particle, h cross is h upon 2 pi, E is the total energy of the particle, Vx is the potential energy of the particle, again u is the wave function of the particle. Now you can see here in region 1 from minus infinite to from actually minus infinite to minus, in region 1 the potential energy is 0, in region 3 from plus a to plus infinite potential energy is 0. So in region 1 from x to minus infinite to minus a the potential energy of the particle is 0, in region 3 from plus a to plus infinite again the potential energy of the particle is 0. So in region 1 from minus infinite to minus a potential energy of the particle is 0, in region 3 from plus a to plus infinite potential energy of the particle is 0. So in region 1 and 3 Schrodinger equation becomes d square u upon dx square plus 2m upon h cross square e minus, in region 1 and 3 potential energy Vx of the particle is 0 into u is equal to 0. So Schrodinger equation becomes d square u upon dx square plus 2m upon h cross square into u is equal to 0. This 2m upon h cross square is a constant term, okay? We define it by minus alpha square. So 2 is positive, mass of the particle is positive, h cross is positive, but the total energy of the particle is negative. So 2m upon h cross square is a negative term, so it is defined by minus alpha square, where alpha is a positive constant. If alpha is a positive constant, then the constant term 2m upon h cross square is defined by minus alpha square, because 2 is positive, m is positive, h cross is positive, but energy of the particle is negative, so left hand side term is negative. So in order to make the right hand side term negative, we have to put negative sign here. Okay, so in region 1 and 3 Schrodinger equation becomes d square u upon dx square, 2m upon h cross square is defined by minus alpha square u is equal to 0. So d square u upon dx square minus alpha square u is equal to 0 is the Schrodinger equation in region 1 and Schrodinger equation in region 3. Now let us write out the solution of this equation. This is the Schrodinger equation for region 1 and 3. Now the solution of Schrodinger equation in region 1, u1x is c raised to alpha x. So solution of Schrodinger equation in region 1, u1x is defined by c raised to alpha x. So solution of Schrodinger equation in region 1, u1x is c e raised to alpha x, where c is unknown constant, e raised to alpha x is exponential function, alpha you know, alpha square is defined by 2m upon h cross square, so alpha is under 2m upon h cross square, and for region 1 the value of x, is from minus infinite to minus x. Similarly in region 3 solution of Schrodinger equation u3x is given by d e raised to minus alpha x, but again d is unknown constant, e raised to minus alpha x is the exponential function, alpha is under 2m upon h cross square, and for region 3 the value of x is from plus a to plus infinite. Okay, so in region 1 the solution of Schrodinger equation u1 is c e raised to alpha x, and in region 3 solution of Schrodinger equation u3 is d e raised to minus alpha x. Now let us obtain the Schrodinger equation in region 2. In region 2 the potential energy is not 0 but it is minus v0, right? So in region 2 the potential energy of the particle Vx is minus v0. So Schrodinger equation in region 2 becomes d square u upon dx square plus 2m upon h cross square e minus, in region 2 the potential energy of the particle Vx is minus v0. So in region 2 the potential energy Vx of the particle is negative minus v0 into u is equal to 0. So d square u upon dx square plus 2m upon h cross square e minus v0 will be e plus v0, u is equal to 0. This 2m upon h cross square e plus v0 is a constant term, it is defined by beta square, where beta is a positive constant, right? So d square u upon dx square plus beta square is equal to 0. So in region 2 the potential energy of the particle Vx is minus v0. So in region 2 Schrodinger equation becomes d square u upon dx square plus 2m upon h cross square e minus, Vx is minus v0, u is equal to 0. So d square u upon dx square plus 2m upon h cross square e minus v0 will be plus v0, u is equal to 0. This 2m upon h cross square e plus v0 is a constant term defined by beta square. So d square u upon dx square plus beta square u to 0 is the Schrodinger equation for region 2. Okay, and solution of Schrodinger equation in region 2 is given by u2x into a cos beta x plus b sin beta x. See, please make one correction in the last lecture. Instead of sin beta x I have written cos beta x. This is my mistake. Okay, so please make the correction. The solution of Schrodinger equation in region 2 u2x is a cos beta x plus b sin beta x. The first term contains cos beta x, second term contains sin beta x. So solution of Schrodinger equation d square u upon dx square plus beta square is equal to 0. solution of Schrodinger equation d square u upon dx square plus beta square is 0 in region 2, that is u2x is a cos beta x plus b sin beta x. So in region 2, I have written the solution here. In region 2, the solution of Schrodinger equation u2 is a cos beta x plus b sin beta x. But what is a and b are unknown constants. A and b are unknown constants, right? Okay, beta is a known constant defined by under root 2m upon h cross square e plus v0. And for region 2, the value of x, the value of x is from minus a to plus a. For region 2, the value of x is from minus a to plus a. Okay, now then after obtaining solution u1 is equal to c raised to alpha x in region 1, solution u3 is equal to b raised to alpha x in region 3, and solution u2 is equal to a cos beta x plus b sin beta x in region 2. Okay, we have discussed the continuity conditions, that wave solution ux has three different forms. u1 in region 1, the solution ux has three different forms. u1 in region 1, u2 in region 2, and u3 in region 3. Okay, the wave function ux and its first derivative du by dx must be continuous everywhere. Okay, so we have four continuity conditions. You can see here at the point x to minus a, at the point x is equal to minus a, where region 1 and 2 meets, there are two continuity conditions. u1 is equal to u2 at the point x to minus a, and du1 by dx to du2 by dx at the point x to minus a. So at the point x is equal to minus a, the left hand side region 1 and right hand side region 2 meets. So u1 must be equal to u2 and du1 by dx is equal to du2 by dx. So at the point x is equal to minus a, where left hand side region 1 and right hand side region 2 meets, the first continuity condition is u1 is equal to u2 and du1 by dx is equal to du2 by dx, at which point x is equal to minus a. Now you know u1, what is u1? u1 is the solution of Schrodinger equation in region 1. What is solution of Schrodinger equation in region 1? C e raised to alpha x, at which point x will minus a. What is u2? Solution of Schrodinger equation in region 2, that is a cos beta x plus b sin beta x at the point x will minus a. So a equation में yes, ये दोनों फंक्शन u1 is equal to u2 is equal to कौन से पॉइंट पे सेम है? x is equal to minus a पर, so you have to put x equal to minus a. So c e raised to minus alpha is equal to a cos x equal to minus a रखेंगे तो cos minus beta है, plus b sin x equal to minus a रखेंगे तो sin of minus beta है. So c e raised to minus alpha is equal to a. Now cos of minus theta is cos theta, so cos of minus beta will be cos beta है, plus b sin of minus beta है. So sin of minus theta is minus sin theta, so sin of minus beta will be minus sin beta, so minus b sin beta. Okay, so this is the first continuity condition from u1 is equal to u2. So I mentioned that condition here. So u1 is equal to u2, which equation we are getting? C e raised to minus alpha है, C e raised to minus alpha है is equal to right hand side a cos beta है minus b sin beta है, a cos beta है minus b sin beta a. This is equation number 6 from the continuity condition u1 is equal to u2. The second continuity condition is which derivatives are same. du1 by dx must be equal to du2 by dx at the point x to minus a. Now d by dx, what is u1? u1 is c raised to alpha x, उसका फर्स्ट डेरिवेटिव लेना है हमको. du2 by dx, so d by dx, u2 क्या है? a cos beta x plus b sin beta x, उसका भी फर्स्ट डेरिवेटिव लेना है, right? So according to the continuity conditions, the wave function ux and its first derivative du by dx must be continuous everywhere. Okay, so c is constant, derivative of e raised to alpha x will be e raised to alpha x into alpha is equal to a constant है, डेरिवेटिव ऑफ cos beta x क्या होगा? माइनस sin beta x into beta प्लस b is constant, sin beta x का डेरिवेटिव क्या होगा? sin beta x का डेरिवेटिव ऑफ sin beta x will be cos beta x into beta. Okay, now we have to put x equal to minus a. So alpha c e raised to minus alpha is equal to a beta sin. Okay, if you put x equal to minus a here, then sin of minus beta है. What is sin of minus beta है? Minus sin beta है. So माइनस माइनस क्या होगा? प्लस ए बीटा साइन बीटा है प्लस बी बीटा कॉस. आप एक्स में माइनस रखेंगे तो कॉस ऑफ माइनस बीटा है. व्हाट इज कॉस ऑफ माइनस बीटा है? कॉस बीटा है. सो बी बीटा कॉस बीटा है. सो फ्रॉम द सेकंड कंटिन्यूटी कंडीशन du1 by dx to du2 by dx we get this equation. du1 by dx is equal to du2 by dx. We get the equation. कौन सा इक्वेशन मिला हमको? अल्फा c e raised to minus alpha है, अल्फा c e raised to minus alpha है is equal to यस a बीटा साइन बीटा है, a बीटा साइन बीटा है प्लस b बीटा कॉस बीटा है, प्लस b बीटा कॉस बीटा है, प्लस b बीटा cos बीटा a. This is equation number 7. A equation number 7 है. Next, see we have two more continuity conditions. We have two more continuity conditions. At the point x is equal to plus a, region 2 and 3 are meeting. So we have two continuity conditions. U2 is equal to U3 and du2 by dx equal to du3 by dx. You can see here at the point x is equal to plus a. At the point x is equal to plus a, the left hand side region 2 and right hand side region 3 bits. So at the right hand side point x is equal to plus a, at the point x is equal to plus a, the left hand side region 2 and right hand side region 3 bits. So u2 is equal to u3 and du2 by dx equal to du3 by dx. So at the point x is equal to, at the point x is equal to plus a, the left hand side region 2 and right hand side region 3 bits. So u2 must be equal to u3 and du2 by dx must be equal to du3 by dx. At which point x is equal to plus a. So x equal to minus a point by u1 is equal to u2 and du1 by dx is equal to du2 by dx. At the point x is equal to, at the point x is equal to plus a, region 2 and 3 minutes. So u2 is equal to u3 and du2 by dx is equal to du3 by dx at the point x is equal to plus a. Okay. Now you know what is u2. u2 क्या है? Solution of Schrodinger equation. आपको ये तीन equation याद रखना है. Solution of Schrodinger equation in region 1 is u1 is c raised to alpha x. Solution in region 2 is a cos beta x plus b sin beta x, and solution in region 3 u3 is d e raised to minus alpha x. So u2 क्या है? Solution of Schrodinger equation in region 2 is a cos beta x plus b sin beta x at the point x plus है. Solution u3 क्या है? d e raised to minus alpha x at the point x plus है. Okay, अब पर x plus है रखेंगे तो क्या मिलेगा? a cos beta a plus b sin beta a is equal to d e raised to minus alpha x. So we will get the equation. This equation 8 from u2 is equal to u3. Okay. So from u2 is equal to u3 we get equation 8 d e raised to minus alpha है, d e raised to minus alpha है. I am writing right hand side of this equation. I am writing right hand side of this equation on the left hand side of this. Okay, because both sides are same. What is the left hand side of this equation? A cos beta a plus b sin beta a. That I am writing on the right hand side. A cos beta a cos beta a plus b sin beta a. Right? So from u2 is equal to u3 we get d e raised to minus alpha is equal to a cos beta a plus b sin beta a. And last condition, du2 by dx, du2 by dx is equal to du3 by dx at the point x plus a. So du2 by dx at the point x plus a must be equal to du3 by dx at the point x plus a. So d by dx, what is u2? A cos beta x plus b sin beta x is equal to d by dx. What is u3? d e raised to minus alpha x. So a constant है, cos beta x का डेरिवेटिव होगा sin beta x into beta. b constant है, सॉरी a constant है, cos beta x का डेरिवेटिव होगा minus sin beta into beta. b constant है, sin beta x का डेरिवेटिव होगा cos beta x into beta. The d constant है, derivative of e raised to minus alpha x will be e raised to minus alpha x into minus alpha, right? But this du2 by dx and du3 by dx are equal at which point? X will plus a. So we have to put x will plus a here. So minus a beta sin beta a plus b beta cos a beta x is a minus alpha d e raised to minus alpha x will be. Okay, so from du2 by dx to du3 by dx we get equation 9. Okay, so from du2 by dx to du3 by dx we get equation minus alpha d is equal to minus a beta sin beta a plus b beta cos beta a. So from u1 is equal to u2 we get the equation c raised to minus alpha is equal to cos beta a minus b sin beta a. From the second continuity condition du1 by dx equal to du2 by dx at the point minus a, we get the second equation alpha c raised to minus alpha is equal to a beta sin beta a plus b beta cos beta a. Now from the third continuity condition u2 is equal to u3 at the point plus a, we have the third equation d e raised to minus alpha is equal to a cos beta a plus b sin beta a. And from the last continuity condition du2 by dx is equal to du3 by dx at the point plus a, we get minus alpha d e raised to minus alpha a is equal to minus a beta sin beta a plus b beta cos beta a. Now our intention is, क्या करना बैठा है, what is our intention? Our intention is all this mathematical exercise we are doing to find the energy eigenvalues of this particle which is inside the square well potential, because the total energy of the particle is negative, so this particle cannot enter in region 1 and 3, so this particle have to stay within the square well, okay, between minus a to plus a, okay. So ये particle की energy निकालने के लिए some mathematical exercise हम कर रहे हैं, right? Now let us do some mathematical. Today's lecture is purely mathematics, okay. So first we take the sum of 6 and 8. चलो equation 6 और 8 का sum करते हैं. So let us, this is equation 6. From u1 is equal to 2, we get equation 6. du1 by dx, du2 by dx, we get equation 7. u2 is equal to 3, we get equation 8. du2 by dx, du3 by dx, we get equation 9. So let us take the sum of equation 6 and 8. चलो 6 के left hand side क्या है, c raised to minus alpha है plus d raised to minus alpha है. So we get c plus d, c plus d e raised to minus alpha is equal to, yes, a cos beta a plus a cos beta will be 2a cos beta a minus b sin beta a plus b sin beta is cancelled, right? So if you take the sum of equation 6 and equation 8, you get c raised to minus alpha a plus d e raised to minus alpha will be c plus d e raised to minus alpha a cos beta a plus a cos beta will be 2a cos beta a minus b sin beta a plus b sin beta will be cancelled. Okay, now let us take 6 minus 8. 6 minus 8. So c minus d equation 6 minus equation 8 will give you c minus d e raised to minus alpha a is equal to, now a cos beta a minus a cos beta is cancelled, minus b sin beta a minus b sin beta will be minus 2b sin beta a minus 2b sin beta. So equation 6 minus 8 gives c minus d e raised to minus alpha is a cos beta minus a cos beta is cancelled, minus b sin beta minus b sin beta will be minus 2b sin beta. Now equation 7 plus 9. Equation 7 plus 9. 7 क्या है? Alpha c e raised to minus alpha है, right? Plus minus alpha d e raised to minus alpha है. So equation 7 plus 9 give you alpha is constant, okay? C plus minus d will be c minus d e raised to minus alpha is equal to a beta sin beta minus a sin beta is cancelled, b beta cos beta plus b beta cos beta will be 2b cos beta, 2b beta cos beta, right? So if you take the sum of equation 7 and 9, you will get alpha is constant, c minus, sorry, if you take the sum of equation 7 and 9, you will get alpha is common, whereas c plus minus d will be c minus d e raised to minus alpha. If you take the sum of 7 and 9, a beta sin beta minus a beta sin beta is cancelled, b beta cos beta plus b beta cos beta will be 2b beta cos beta. And last, 7 minus 9, equation 7 minus 9. So 7 minus 9 will give you alpha तो common है, c minus minus क्या होगा plus d e raised to minus alpha. So equation 7 minus 9 gives alpha is common, c minus minus d will be plus d e raised to minus alpha is equal to a beta sin beta minus minus plus a beta sin beta will be 2a beta sin beta. A beta sin beta minus minus plus a beta sin beta will be 2a beta sin beta, right? B beta cos beta minus b beta cos beta will be cancelled out. So if you take the 7 minus 9, it will give you alpha is common, c minus minus plus d e raised to minus alpha, a beta sin beta minus minus plus a beta sin beta will be 2a beta sin beta, b beta cos beta minus b beta cos beta will be cancelled, right? Okay. So all in this equation, what you have to remember, this a, b, c and d. A, B, C, D are unknown constants. A, B, C and D are unknown constants. Alpha is a known constant. Alpha का equation क्या है? Alpha square is 2m upon h square. So alpha is under root 2m upon h square. And beta square क्या है? Beta square is a known constant. Beta square is 2m upon h square e plus b zero. So beta का equation होगा under root 2m upon h square e plus b zero. So A, B, C, D are unknown constants. ABCD are unknown constant, and alpha square is equal to 2m upon h cross square, and beta square 2m upon h cross square plus b0 are known constants. Okay, now let us take some calculations, do some calculations. इक्वेशन 13 अपॉन 10 करेंगे तो क्या मिलेंगे? 13 क्या है इक्वेशन? इक्वेशन 13 के लेफ्ट हैंड साइड क्या है? अल्फा c प्लस डी e रेज टू माइनस अल्फा है डिवाइडेड बाय, इक्वेशन 10 के लेफ्ट हैंड साइड क्या है? c प्लस डी e रेज टू माइनस अल्फा है. The right hand side of equation 13 is 2a beta sin beta है, 2a beta sin beta है. इक्वेशन 10 के राइट हैंड साइड है 2a cos beta है, 2a cos beta है. Okay, so equation 13 upon 10 gives the left hand side of equation 13 is alpha c plus d e raised to minus alpha है divided by c plus d e raised to minus alpha है is equal to right hand side of equation 13 is 2a beta sin beta है upon right hand side of equation 10 is 2a cos beta है. Okay, now if you take the, yes, you can see here that c plus d you can cancel. Okay, लेकिन आप c plus d को तब कैंसिल कर सकते हैं when c plus d is not equal to 0. When c plus d is not equal to 0, then you can cancel c plus d and c plus d. So c plus d is cancelled provided c plus d is a non-zero constant. If c plus d is not equal to 0, then you can cancel c plus d. 2 तो नॉन जीरो कॉन्स्टेंट है तो 2 को आप कैंसिल कर सकेंगे. अभी आपको a को कैंसिल करना है तो a is not equal to 0, right? If you want to cancel a, then if a is not equal to 0, a is not equal to 0, then a is cancelled, right? Okay, e raised to minus alpha है पॉजिटिव है तो उसको तो आप कैंसिल कर सकते हैं, राइट? सो c plus d is not equal to 0, then c plus d is cancelled. e raised to minus alpha है पॉजिटिव है तो वो तो कैंसिल हो जाएगा. 2 पॉजिटिव है, राइट? सो नॉन जीरो कॉन्स्टेंट है, सॉरी 2 इज अ नॉन जीरो कॉन्स्टेंट, सो 2 कैन बी कैंसल. e को कैंसिल करना है तो a is not equal to 0, then you can cancel it. So c plus d is not equal to 0, then c plus d is cancelled. a is not equal to 0, then a is cancelled. 2 तो नॉन जीरो है तो कैंसिल हो जाएगा. e raised to minus alpha है नॉन जीरो, वो भी कैंसिल हो जाएगा. तो लेफ्ट साइड में क्या बचा है? अल्फा इज इक्वल टू, राइट साइड में क्या है बच्चा? 2a कैंसिल हो गया, सो बीटा साइन बीटा है अपन कॉस बीटा है, क्या होगा? टेन बीटा है. दिस इज इक्वेशन नंबर 14, right? So if you take the equation 13 upon equation 13, alpha c plus d e raised to minus alpha is equal to 2a beta sin beta divided by equation 10 c plus d e raised to minus alpha 2a cos beta है. This c plus d is not equal to 0, then c plus d is cancelled. e raised to minus alpha है not equal to 0, so cancel हो जाएगा. 2 not equal to 0 cancel हो जाएगा. a not equal to 0 तो a भी cancel हो जाएगा. तो we get alpha is equal to beta and sin beta upon cos beta is tan beta. So alpha is equal to beta tan beta is one type of solution. In this equation you should know what is alpha. Alpha आपको मालूम होना चाहिए क्या है? Alpha is under root 2me upon h cross square. It is a known constant. What is beta? Beta is also a known constant. It is under root 2m upon h cross square e plus v0. What is a? A क्या है? A is the width of the potential valve and v0 is the depth of the potential valve, right? So alpha is equal to beta tan beta is one type of solution, okay? With condition c plus d is not equal to 0 and a is not equal to 0. When c plus d is not equal to 0, it implies c minus d is equal to 0. Therefore, for this solution, c and d are equal. And when a is not equal to 0, at that time b is equal to 0, okay? This condition you can prove, but due to the shortage of time, we are not going to prove this. But you remember in this way that c plus d is not equal to 0, it implies c minus d is equal to 0, means for this solution, c and d are same. So when c plus d is not, when c plus d is not equal to 0, it implies c minus d is equal to 0, means two constants c and d are equal. For the first type of solution, alpha is equal to beta tan beta a. For the first type of solution, alpha is beta tan beta a. c plus d is not equal to 0. When c plus d is not equal to 0, it implies c minus d is equal to 0, means c and d are equal. So for the first type of solution, alpha is equal to beta tan beta a, c plus d is not equal to 0, therefore it implies c minus d is equal to 0, therefore c is equal to d. So for alpha is equal to beta tan beta a, two constants c and d are equal, same, okay? For alpha is equal to beta tan beta a solution, a is not equal to 0, it implies b is equal to 0. अगर a 0 नहीं तो b को 0 होना पड़ेगा, right? Okay, now next. So alpha is equal to beta tan beta a is first type of solution, one type of solution we are getting, okay? Now equation 12 upon 11. Equation 12 क्या है? Alpha c minus d e raised to minus alpha divided by c minus d e raised to minus alpha is equal to 12 क्या है 2 b beta cos beta है divided by right hand side क्या इक्वेशन माइनस 2 beta 2b sin beta है. Please see the difference. b and beta are different. b is a unknown constant. b is a unknown constant and beta is a known constant. beta क्या है under root 2m upon h cross square e plus v0. So equation 12 upon equation 11 gives the left hand side of equation 12. The left hand side of equation 12 is alpha c minus d e raised to minus alpha upon left hand side of equation 11 is c minus d e raised to minus alpha is equal to the right hand side of equation 12 is 2b beta cos beta divided by right hand side of equation 11 is minus 2 beta sin beta. So equation 12 upon 11 gives alpha c minus d e raised to minus alpha upon c minus d e raised to minus alpha is equal to 2b beta cos beta divided by minus 2 beta sin beta. इधर भी हमको कंडीशन रखनी पड़ेगी. देखो e raised to minus alpha is a non-zero. e raised to minus alpha is non-zero, so it can be cancelled out. 2 is non-zero, so 2 is cancelled out. Because it 0 होगा तो अगर डिनोमिनेटर is 0 then this will be infinite. That is why e raised to minus alpha is non-zero. e raised to minus alpha is non-zero, so it can be cancelled. 2 is non-zero, so it can be cancelled. Now c plus d को आपको cancel करना है, तो you have to put the condition that c minus d is not equal to 0. If c minus d is not equal to 0, then you can cancel c minus d. If c minus d is not equal to 0, non-zero, then you can cancel c minus d from numerator and denominator. So left hand side में क्या बचा alpha is equal to minus, right? Okay. Right hand side में b को cancel करना है आपको. If you want to cancel b, then b is not equal to 0. So b is not equal to 0. You can cancel out b from the right hand side. So right hand side में क्या बचा beta. This cos beta upon sin beta will be cot beta. Okay. So this is equation number 15. Equation number 15. That if c minus d is non-zero, then c minus d is cancelled. If b is non-zero, then b is cancelled. Therefore, alpha is equal to minus beta cos beta upon sin beta will be cot beta. So alpha is equal to minus beta cot beta is the second type of solution. Alpha is equal to beta tan beta is one type of solution, and alpha is equal to minus beta cot beta is the second type of solution. That c minus d is not equal to 0, then c minus d is cancelled. b is not equal to 0, then b is cancelled. So left hand side we have alpha is equal to right hand side we have minus beta, and cos beta upon sin beta will be cot beta. So alpha is equal to minus beta cot beta is the second type of solution with the condition c minus d is not equal to 0 and b is not equal to 0. अगर c minus d 0 नहीं है तो c plus d is equal to 0 होगा. Therefore c is equal to minus d होगा. और b is not equal to 0 है तो उसका मतलब a is equal to 0 होगा, right? This condition we can prove, but as I told you, due to the shortage of time, we are not going to prove this. Okay. So for the first type of solution, alpha is equal to beta tan beta. What are the conditions? C plus d is not equal to 0. It implies c minus d is equal to 0. Means c and d are equal. A is not equal to 0. Therefore, constant b is equal to 0. For the second type of solution, alpha is equal to minus beta cot beta. What are the conditions? C minus d is not equal to 0. Therefore, it implies c plus d is equal to 0. होगा. So c and d will be same, but c is equal to minus d. b is not equal to 0 for second solution alpha minus beta cot beta. So for the second solution alpha minus beta cot beta, b is not equal to 0. It implies a is equal to 0. Okay. So in this way, from the continuity conditions, we got two solutions. One solution is alpha is beta tan beta, and the other solution is alpha is equal to minus beta cot beta. Okay. Now from the first solution, alpha is equal to beta tan beta a. We consider this equation c plus d e raised to, for alpha is equal to beta tan beta, you can see here, for alpha is equal to beta tan beta, you can see here that c is equal to d here. C is equal to d here. Okay, so for the first solution alpha is equal to beta tan beta a, we have कौन सी कंडीशन है? फॉर द फर्स्ट सॉल्यूशन अल्फा इज इक्वल टू बीटा tan beta a, c plus d is not equal to 0. It implies c minus d 0 means c and d are equal, and a is not equal to 0, therefore b is equal to 0. Okay, so for the first solution alpha is equal to beta for the first solution, first type of solution alpha beta and beta m. We have c is equal to d. Okay, so let us take this continuity condition. ये सन लेता है इक्वेशन 10 c plus d e raised to minus alpha है is equal to 2a cos beta है. इक्वेशन 10 लेते हैं. चलो इक्वेशन 10 क्या है फिर से देखते हैं. इक्वेशन 10 is c plus d. इक्वेशन 10 is the sum of equation 6 and 8. c plus d e raised to minus alpha is equal to 2a cos beta है. Now for the first solution alpha is equal to beta and beta है. c plus d is not equal to 0. It implies for the first type of solution alpha beta and beta है. c plus d is not equal to 0. It implies c minus d is equal to 0 means c is equal to d. तो पहला सॉल्यूशन के लिए c is equal to d है. तो let us put c is equal to d in this equation. तो c is equal to d रखेंगे तो d plus d e raised to minus alpha है is equal to 2a cos beta है. याद रखना है इसे. a is not equal to 0. Alpha is equal to beta and beta solution के लिए c and d are equal and a is not equal to 0. Okay. So in the equation 10 c plus which is the sum of equation 6 and 8 c plus d e raised to minus alpha a cos beta plus c cos beta 2a cos beta है. Let us put c is equal to d. If you put c is equal to d we have d plus d e raised to minus alpha is equal to 2a cos beta है. Now d plus d will be 2d. Okay. Now 2 is cancelled from both the sides. The value of d comes a cos beta a e raised to minus alpha I am writing on right side, so it will become e raised to plus alpha a. Okay, so this is the value of constant d. This is the value of constant d. A cos beta a e raised to alpha a for the first type of solution alpha will be beta and beta a and c and d are same. So अगर d की वैल्यू a cos beta e raised to alpha है तो c की वैल्यू भी कितनी होगी a cos beta e raised to alpha है. A is not equal to 0 and b is equal to 0. Okay, now similarly for the second type of solution alpha is minus beta cot beta, let us find out the value of d. So for the second type of solution alpha is equal to minus beta cot beta a. For the second type of solution alpha is equal to minus beta cot beta a. C minus d is not equal to 0. For the second solution alpha is equal to minus beta cot beta. For the second type of solution alpha is minus beta cot beta. C minus d is not equal to 0. Therefore c plus d is equal to 0. If c plus d is equal to 0 then c is equal to minus d. तो इस सॉल्यूशन के लिए c is equal to क्या है minus d and b is not equal to 0, therefore a is equal to 0. b is not equal to 0. Okay. So for the second type of solution, alpha is equal to, for the second type of solution alpha is minus beta cot beta, c minus d is not equal to 0, therefore c plus d is equal to 0, therefore c is equal to minus d and b is not equal to 0, therefore a is equal to 0. Okay. Now let us put the value c is equal to minus d in the equation 11, which is c minus d e raised to minus alpha है minus 2b sin beta है. So this is equation number 11. What is equation 11? That is 6 minus 8. What is 6 minus 8? c minus d. 6 minus 8 gives c minus d e raised to minus alpha है. a cos beta is cancelled. Minus b sin beta minus 2b sin beta. Equation 11 में, so equation 11 is 6 minus 8 c minus d e raised to minus alpha जो a cos beta minus cos beta cancel minus b sin beta minus b sin beta minus 2b sin beta. ये equation में हमको रखना है c is equal to minus d. So let us put c is equal to minus d in this equation. So c is equal to minus d e raised to minus alpha a is equal to minus 2b sin beta है. Minus d will be 2d e raised to minus alpha है. Okay. Therefore value of constant d for the second type of solution is, okay, ये minus 2 cancel हो जाएगा, so b sin beta है. If I write e raised to minus alpha on right side, it will be e raised to plus alpha है. So this is the value of d for the second type of solution. So for the first type of solution, alpha is equal to beta and beta, c is equal to d, a is not equal to 0. The value of d is a cos beta e raised to alpha. For the second type of solution, alpha is equal to minus beta cot beta A, C is equal to minus D, B is not equal to 0, and value of constant D is B sin beta A e raised to plus alpha A. Okay, now our main target, main aim is to find out the energy eigenvalues of the particle which is inside the potential well. Our aim क्या है? We want to find out the energy eigenvalues of the particle which is inside the square well. Square well के अंदर जो particle उसकी energy निकाल रहा है. So we want to find out the energy eigenvalues of the particle which is inside the potential band between minus and plus A. Okay, so let us now move to the next step to find the energy eigenvalues of the particle inside the potential square well potential, right? Okay, so let us now move to the next step to find the energy eigenvalues of the particle which is bound between minus A and plus A. So let us now calculate the energy eigenvalues of the particle which is inside the square well between minus and plus A. Now we can see here that we have obtained two solutions. One solution is alpha is equal to beta tan beta A, right? And second solution is alpha is equal to minus beta cot beta A. So we can now see that both types of solution. First type of solution alpha is equal to beta cot tan beta A, and the second type of solution alpha is equal to minus beta cot beta A exists only for certain discrete values of the energy. सब कोई भी एनर्जी के वैल्यूज के लिए both the solutions are not existing. Okay, alpha is equal to beta tan beta A and alpha is minus beta cot beta A solutions exist for certain discrete values of energy, and that discrete values of energy E is nothing but that is the energy eigenvalues of the particle inside the square well potential, right? So we can now see that let us now see that the both types of solution, the first type of solution alpha is beta tan beta A. Let us now see that both types of solution, first type of solution alpha is beta tan beta A and second type of solution alpha minus beta cot beta A exist only for certain discrete values of energy, right? Okay, so let us now see that both types of solution, first type of solution alpha is beta tan beta A and second type of solution alpha minus beta cot beta A exist only for certain discrete values of energy, and that discrete values of energy E is nothing but that is the energy eigenvalues of the particle inside the square well. तो स्क्वायर वेल के अंदर जो पार्टिकल है उसकी एनर्जी आइगन वैल्यूज मिलेगी हमको. नाउ यू नो दैट वी हैव डिफाइंड अल्फा स्क्वायर क्या है? सी अल्फा स्क्वायर, यस, दिस अल्फा स्क्वायर इज डिफाइंड बाय 2me अपॉन h क्रॉस स्क्वायर. अल्फा स्क्वायर इज डिफाइंड बाय 2me अपॉन h क्रॉस स्क्वायर. And beta square को डिफाइन किया है 2m upon h cross square e plus v0. So alpha square is defined by 2me upon h cross square is defined by minus alpha square, and beta square is defined by 2m upon h cross square e plus v0. So beta square is equal to 2m upon h cross square e plus v0, right? Okay. So we have two constants. Alpha square is defined by minus 2me upon h cross square. Okay. Alpha square is minus 2me upon h cross square is defined by minus alpha square. 2me upon h cross square is defined by minus alpha square, and beta square is defined by 2m upon h cross square e plus v0. If I take the sum of alpha, two constants alpha square beta square, we get alpha square. Constant alpha square is defined by minus 2me upon h cross square plus beta square is defined by 2m upon h cross square e plus v0. Okay, so let us take the sum of two constants alpha square plus beta square. Alpha square is defined by constant alpha square is defined by minus 2me upon h cross square. Alpha square is defined by minus 2me upon h cross square. Beta square is defined by 2m upon h e plus v0. So let us take the sum of alpha square plus beta square. Alpha square is minus 2me upon h cross square plus beta square is 2m upon h cross square e plus v0. So alpha square plus beta square is equal to minus 2me upon h cross square plus 2me upon h cross square plus 2m upon h cross square into v0. So alpha square plus beta square is minus 2me upon h cross square. I separate this term into two parts, 2m upon h cross square into e plus 2m upon h cross square into v0. So alpha square plus beta square is minus 2m upon h cross square. I separate this term into two parts, 2m e upon h cross square plus 2m v0 upon h cross square. Now this minus 2m upon h cross square and plus 2m upon h cross square is cancelled out. So alpha square plus beta square is equal to, we are getting 2m upon h cross square into v0. Now I multiply both sides by a square. Multiply by a square on both sides. What is a? You know, width of the potential well. Width of potential well. Okay. You know very well. This V0. V0 क्या है? V0 is the depth. V0 is the depth of potential well and A is the width of the potential well. So V0 is the depth of potential well and A is the width of the potential well. So let us multiply both sides of this equation with A square on both sides, where A is the width of potential well. Okay. So alpha square plus beta square. I multiply this alpha square beta square with A square. A square is equal to 2m upon h cross square. I also multiply this equation with a square. So लेफ्ट साइड में मैंने स्क्वायर से डिवाइड किया, सॉरी मल्टीप्लाई किया, राइट हैंड साइड में भी स्क्वायर से मल्टीप्लाई किया. ओके, सो लेट अस मल्टीप्लाई this equation by with a square on both the sides, where a, you know, that is the width of the potential well. We get alpha square plus beta square is multiplied with a square is equal to 2m v0 upon h cross square multiplied with a square, right? So we get alpha square plus beta square into a square is equal to v0 upon h cross square 2m square. I am writing in denominator, right? Okay, so alpha square plus beta square a square is equal to v0 upon h cross square. This 2m term I am writing in denominator, h cross square upon 2m square. This h cross square upon 2m square is called delta. So alpha square plus beta square into a square is equal to v0 upon delta. So we are getting this equation, alpha square plus beta square into a square is equal to v0 upon delta. I give the equation number. I give the equation number. मैं कितने इक्वेशन डाल के 14, 15 16, right? So once again I quickly repeat that let us go to the next article. The next topic, the energy eigenvalues of the particle inside the square well, which has discrete values. We can now see that. Let us now see that both types of solution. Let us now see that both types of solution. First type of solution alpha is equal to beta and beta, and second type of solution alpha minus beta got beta exist only for certain discrete values of energy. Okay, for all values of energy, these solutions do not exist. Only for certain discrete values of energy, these solutions are existing. And that values of energy for which both the solution exist are called the energy eigenvalues of this particle inside the square well. Okay, now let us take the sum of alpha square and beta square. So alpha square plus beta square is equal to, alpha square is minus 2m upon h cross square plus beta square is 2m upon h cross square e plus v0. So alpha square beta square is minus 2m upon h cross square. This term को हम दोनों में सेपरेट करते तो 2m upon h cross square into e plus 2m upon h cross square into v0. This minus 2m upon h cross square plus 2m upon h cross square is cancelled. So we have alpha square plus beta square is 2m upon h cross square v0. Let us multiply left hand side and right hand side with a square, where a is the width of the potential well. So we get alpha square plus beta square into a square is equal to 2m a square v0 upon h cross square. This equation may be written as alpha square plus beta square into a square is equal to v0 upon h cross square, or 2m square में denominator में लिखता हूँ h cross square upon 2m square. So alpha square plus beta square into a square is equal to v0 upon h cross square upon 2m square. This h cross square upon 2m square is called delta. Okay, so we have alpha square plus beta square into a square is v0 upon delta. That is equation number 16. Okay, you know very well, सब टर्म्स आपको याद रखना है. अल्फा स्क्वायर क्या है? नॉन कांस्टेंट है. which is minus 2me upon alpha square is a known constant, minus 2me upon h cross square. Beta square is a known constant, 2m upon h cross square e plus v0. So alpha square is a known constant defined by minus 2me upon h cross square. Beta square is a known constant defined by 2m upon h cross square e plus v0. A क्या है? Half width A is the width of the potential well. A is the width of the potential well on right side and left side of the origin. And v0 क्या है? Depth of the potential. Right. Now, if A is the width of the potential well और a particle well के अंदर है, तो उसकी पोजीशन में अनसर्टेनिटी कितनी मिलेगी? A जितनी, right. Suppose the width of the potential well is A, then the uncertainty in the position of the particle is maximum uncertainty will be A. So delta x is equal to A. Delta x is equal to A. Delta x is equal to A is the uncertainty in the position of the particle within the square well. A particle square well के अंदर है. A particle square well के अंदर है. What is the width of the square well? A. So what is the maximum uncertainty in the measurement of position of the particle? Delta x is A. So particle a square well के अंदर है. Particle is within the square well. The width of the square well is A. So a particle square well के अंदर है. Square well की width है. तो the maximum uncertainty in the measurement of the position of the particle is A. This is similar to this. Suppose आपको रूम के अंदर है. The length of the room is L. तो आप L लेंथ के रूम के अंदर किधर भी हो सकते हैं. लेफ्ट साइड की वॉल पे होते हैं, राइट साइड की वॉल पे होता है, बीच में भी हो सकते हैं. So the length of the room is L and you are inside the room of length L. Then the maximum uncertainty in the measurement of position is L. Right? So अगर कोई रूम की लेंथ L है और आप रूम के अंदर है तो maximum uncertainty in the measurement of the position is L. Similarly, a particle is within the square well. Particle is within the square well and the width of the square well is A. So maximum uncertainty in the measurement of position of the particle is A. Right? So particle square well के अंदर है. The width of the square well is A. So maximum uncertainty in the measurement of the position of particle is A. So delta x is equal to A is the uncertainty in the position of the particle. Now you know the uncertainty relation. You know the Heisenberg uncertainty relation. Delta x into delta p is of the order of h cross. Delta x is the uncertainty in position into delta p is the uncertainty momentum. It is of the order of h cross. So uncertainty in momentum delta p is equal to h cross upon delta x. Right? So uncertainty according to Heisenberg uncertainty principle, uncertainty in position delta x into uncertainty in momentum delta p is of the order of h cross. So uncertainty in momentum delta p is h cross upon delta x. So uncertainty in momentum delta p is h cross upon. Now what is the uncertainty in the position of the particle A? So h cross upon A. So h cross upon A is the uncertainty in the momentum of the particle, right? And similarly, let us find out the uncertainty in the energy of the particle. So what is the energy of the particle? P square upon 2m. So uncertainty in the energy of the particle delta E is will equal to delta P square upon 2m. Now what is delta P? H cross upon A. H cross upon A whole square upon 2m. So uncertainty in the energy will be H cross square upon 2m square. So I have written three uncertainties. Uncertainty in position, uncertainty in momentum, uncertainty in energy. That particle is inside the square well of width A. So अगर particle square well के अंदर है, the particle is inside the square well and the width of the potential square well is A. Then the uncertainty in the measurement of position of the particle inside the square well delta x A. So particle is inside the square well, the width of the square well is A. Then uncertainty in the position of the particle delta x is A. Okay. Now from the Heisenberg uncertainty principle, uncertainty in position delta x into uncertainty in momentum delta p is of the order of h cross. So uncertainty in momentum delta p is equal to h cross upon delta x. So uncertainty in momentum of the particle delta p is h cross upon, okay, and this delta x uncertainty in position of the particle is A. So uncertainty in momentum of the particle delta p is h cross upon uncertainty in the position of the particle inside the square well is A. So h cross upon A is the uncertainty in momentum. You know the equation of energy, E is equal to p square upon 2a. So uncertainty in the energy of the particle delta E is uncertainty in momentum delta p square upon 2m. What is the uncertainty in momentum h cross upon a square upon 2m. So delta is equal to h cross square upon 2m square is the uncertainty in energy. So delta x is the uncertainty in position of the particle. Delta p is equal to h cross upon is the uncertainty in momentum of the particle. And delta is equal to h cross square upon 2m square is the uncertainty in the energy of the particle. So this h cross square upon 2m square which we have defined by delta is nothing but is the uncertainty in the energy of the particle. So the corresponding energy delta is equal to h cross square upon 2m square is a natural unit in terms of which the depth of the potential may be measured. A V0 upon term, so V0 क्या है? Yes, potential energy of the particle. उसका unit है joule. Delta क्या है? Uncertain in energy. तो V0 भी potential energy है, delta भी energy है, तो energy upon energy means dimensionless. So alpha square plus beta square into a square. V0 क्या है? Potential energy of the particle. उसका unit होगा joule. Delta क्या है? H cross square upon 2m स्क्वायर. h क्रॉस स्क्वायर अपॉन 2m क्या वो भी एनर्जी है, उसका यूनिट भी जूल है. सो v0 अपॉन डेल्टा इज अ डायमेंशन लेस क्वांटिटी. डायमेंशन लेस क्वांटिटी. दिस v0 अपॉन डेल्टा इज कॉल्ड स्ट्रेंथ ऑफ द पोटेंशियल. उसको क्या बोलता है? स्ट्रेंथ ऑफ पोटेंशियल. इफ द स्ट्रेंथ ऑफ द पोटेंशियल इज लेस, okay, strength of the potential you can take different values of the strength of the potential. अगर v0 upon delta की value less है तो you can say strength of the potential is less. If v0 upon delta has more value then we can say strength of the potential is more. So the unit of v0 potential energy v0 is joule. Delta is equal to h cross square upon 2m square is also having a unit of energy joule. So v0 potential energy है, उसका unit भी joule है. Delta is equal to h cross square upon 2m square भी एनर्जी है, उसका यूनिट भी जूल है. सो v0 upon delta is a dimensionless parameter. This v0 upon delta is called the strength of the potential. Okay, and the strength of the potential has different values. So in the next lecture we will plot the graphs for different values of v0 upon delta, and we will find out the energy eigenvalues of particle inside the square well. Thank you so much. We stop here. This is the end of lecture 12.